So let's talk about the flash types. Again, we'll begin with the cloud flash. We call cloud flashes intercloud flash activity or intercloud flashes, and those are the flashes that remain within the thunderstorm, or they may extend outside the thunderstorm, but they do not touch the ground. And the development of a lightning flash actually occurs in between the charge regions, and it is believed that it occurs in the area where the highest electric field value is, in between those charge regions. And so somewhere along this pathway in between the two charge regions is where the leader is going to initially develop. And in this case, where we have a normally charged thunderstorm with an upper positive charge region, mid negative charge region, we get a negative leader propagating towards a positive charge, and it actually propagates into and through the positive charge area. It's driven by the electric field difference, or the strength of the electric field between the tip and the cloud charge, the potential difference, and it is driven from that, and so therefore it actually propagates into the charge region. One scientist referred to this as a potential well. So it has this potential difference, and it'll go into this well of potential that is generated by the charge there, and tries to fill up this well and fill up the volume with the leader. At the same time, a positive leader will travel towards the negative charge region and propagate into and throughout the negative charge region. And in this case, this is how most intercloud flashes occur. About 90% of all flashes are cloud flashes that don't reach the ground, and this is the most common type. You can have it occur between any two charge regions, but you need these two charge regions to create an electric field in order for it to occur. And so you can also get it between this lower positive charge region and main negative charge region. And in reality, there's this simple tripole model. As a storm develops, the simplicity of the charge region changes with time, and it can become quite complex with multiple charge regions. So again, we're sticking to the traditional simple charge tripole model. I want to just briefly, while we're here talking about cloud flashes, talk about some transient luminous events. And these are luminous events that occur in the upper atmosphere. In a thunderstorm, we're talking up to probably 20 kilometers maximum as far as the height of the storm itself. And there are some cloud flashes that can generate a transient luminous event. And there's two types. There's a blue jet or a gigantic jet. And these are actually resulting or part of cloud flashes. And this was shown by the scientists at New Mexico Tech very clearly in one of the papers they produced in 2008, showing, based on the LMA data, how these flashes develop. And in the case of a gigantic jet, the gigantic jet is a cloud flash in which you have the main negative charge region and a positive charge region above, and as the negative leader goes into the positive charge region, it continues beyond and up out of the cloud and continues upward. Now the upper ionosphere is positively charged itself, so there is a force of attraction from negative leaders upward, but this essentially continues beyond, whether there's just a smaller region and that it fills up that potential well that I talk about, and tries to continue on beyond that potential well, or that it's been eroded due to mixing with the air nearby, and the amount of positive charge has been reduced. But if you have the positive leader end traveling through the negative charge region, and the negative leader into the positive charge region, and it exits and continues up, it can actually continue up as what we call a gigantic jet. Now this blue that I'm depicting is depicting the fact that in the rarefied air, as you get up higher in altitude and lose pressure and density, the leader no longer propagates as a leader. It transitions back to a streamer. The air is not dense enough to have a kinetically thermalized lightning leader travel up into the upper atmosphere. And therefore, even though there's breakdown that's driven by the electric field and the leader activity, it transitions to a streamer. And this streamer activity that we see above the storm is actually the gigantic jet. So the blue depicts the polarity. In this case, it would be a negative streamer that goes up into the upper atmosphere. The gigantic jets themselves can appear as blue and red, and that's due to nitrogen, the emission of nitrogen, excitation and emissions from nitrogen in the blue and red spectrum. So I'm not trying to depict what they look like in this chart. I'm simply trying to show polarity of development, in this case a negative streamer. Now there's another type called a blue jet, and in the same case it's a cloud flash in which you have negative leader going down into a positive charge region and the positive leader going up towards negative charge. And typically what we think is occurring is that this is either a much smaller screening layer of negative charge or some kind of mixed out negative charge, but now we have a positive leader that's exiting the cloud, continuing up, and then transition again to a streamer, but this is a positive streamer. So the electron direction, the electron movement is actually downward in this particular case as the blue jet rises up. And blue jets tend to not go as high, much shorter in altitude. Sometimes we get what we call blue starters, in which you actually see this channel visible and it only goes up a little ways. So both of those are the result of a cloud flash. They're part of a cloud flash. So they literally are part of the lightning flash. We'll get into later sprites, which are not part of the cloud flash. They're initiated by cloud-to-ground lightning in the underlying storm, but they're separate ionization, breakdown, emissions of gases, excited gases, due to the electric field change from lightning activity, and they occur separately and they're not tied to the storm. In those cases, what we're seeing is a big positive CG flash in which we have negative charge or negative leaders moving through the positive charge region. These negative leaders create a field change. Again, the upper ionosphere is positively charged, so you're enhancing the negative field, enhancing the electric field between the thunderstorm and the ionosphere to the point that you get ionization breakdown in the form of streamers in the upper atmosphere around the 60-kilometer range. And again, this is a bipolar process in which negative streamers go up towards the ionosphere, which is positively charged. You get positive streamers coming down towards the negative charge that was introduced by the negative leaders that occurred on the return stroke that occurred during the positive CG flash. And so we get these sprites that are formed. So we'll talk a little more about TLEs, how they're formed, and types of flashes that form them. But I just want to, since we're talking about cloud flashes right now, I wanted to show that these two cloud flashes, the blue jet and the gigantic jet are actually part of a cloud flash, unlike the sprites. So here's a really nice example of a gigantic jet by J.J. Rayo of Australia, who documents lightning in northwestern Australia. Just a beautiful example. So you can see that we got a flash going on here, and then it rises up, and now we get the transition to the streamer. The bluer colors, again, due to nitrogen in the lower atmosphere, and again, nitrogen transition due to the air density and level of excitation to a more red color as the streamer continues upward higher. And Hank Shima, also known as Pecos Hank, provided me with this blue jet that he captured. And again, here you can actually see the leader channel as it transitions to a streamer. And again, primarily only blue, much lower altitude termination, again due to the nitrogen. So now that we understand cloud flashes, in the next section we're going to take a look at ground flashes. And then in that case, one end of the leader structure extends beyond the thunderstorm cloud and comes down and makes contact with the ground.